Hey, boys and girls, Mr. Mac. Today we're going to be working on Module 7, Lesson 1, which is using benchmarks and number sense to estimate. So we're going to be estimating fractions today. When we are estimating our fractions, we're going to be estimating to 0, 1/2, and a whole. So let's take a look at our Spark Your Learning example here. Ms. Fong mixes water, glue, and laundry detergent together to make slime. The amount of each ingredient is a fraction of a liter. Use a visual model to estimate the total number of liters of ingredients she mixes together. So usually when we start out a lot of these problems, we start with our whole number. Okay. And I like to take my half and I like to bring my half in and put it on top of my whole number because this way I know that this number down here would be 0. There's nothing there. Here is my half, and then this is my whole. So when I'm putting my new fractions underneath of this, when I'm estimating, I want to see what are we closest to? Are we closest to 0? Are we closest to a half? Or are we closest to 1 whole? So it says we have 3/8. So I'm going to go to my fraction tiles, and I'm going to pull out 3 of the eighths. Okay, so 1, 2, 3. That represents 3/8, which is the amount of the water we have. Then we have 2/5 of glue. So I'm going to go 1, 2 fifths of glue. Put them right next to each other as best I can. And we have 1/10 of the laundry detergent. So what I'm looking at now is a model on the bottom here with the eighths, fifths, and tenths of all the ingredients that were used to make the slime. So if we're estimating, trying to understand what is close to, I need to know is 1/10 closest to a whole, which is here, a half, which is here, or 0, which is here. And I'm not asking the 1/10, I'm asking the end of the 1/10 here. Clearly, it's closest to 1/2. So if I wanted to estimate how much of a liter we were using, this would be about, and I put this little squiggly equal sign, about 1 liter. Okay, because it is closest to the 1 whole here, right? Using the fraction tiles is one really great way to estimate our rounding problems, but also we could use a number line, right? Now, if I was using a number line here, and I needed to estimate 3/8, 2/5, and 1/10, I might then estimate each of those on their own. So if I have 3/8, here's my 0, here's my whole. Okay, so 3/8 might be, I need 8 spots. So this is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then 8/8 is 1 whole. So 3/8 would be right here. If I'm trying to round 3/8, I would say, well, I know that half of 8 is 4. So to get, this is where the half is, and 0 is all the way back here. So I know that 3/8 would be about 1/2. Okay, let's do the same thing for the 2/5. If I'm using my number lines and I have 0 holes and then 1 here, I need 1, 2, 3, 4, 5. And I try to make those spaces each about the same distance, right? So if I have 2/5, 2/5 would fall here. Now, I know that when we have 5, finding half of 5 is really difficult when we have these odd numbers. But when I'm looking at the number line above, I knew that a half, 1, 2, 3, 4, fell right around in this area, right? So I know a half is right around that number. Well, is this close to a half or is this close to 0? Again, it's still close to half, so I would say that rounds to half. Now, when we look at 1/10, I'm going to draw the picture, but I don't think we really need to because we know that 1/10 is really close to 0, right? Because it's only 1 of the 10 that we need, right? Half of 10 is 5, right? So 1/10, to get to 5, you need 4 more. But to get to 0/10, you only need to lose 1. So same idea if we drew our fraction line here. Okay, and I said 0 and 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10/10 again as the whole. If I have 1/10 here, I'm like right next to the 0. So then I would have 1/2 plus 1/2 plus 0, which would then give us just the 1. All right, so then this estimate where I had with my models above my fraction strip saying that I have about 1 liter proves to be correct, even if we round each individual fraction and then add them together. All right, now, if we are dealing with estimating with fractions of mixed numbers, and we had, let's say, 36 and 2/5, and we wanted to round that, my 36, I'm not going to worry about that 36 at all. I'm just going to look at the 2/5 here and say, okay, well, if I'm rounding with 2/5, what's that going to look like? So this example was 2/5. And we said it rounded to a half. So 36 and 2/5 is close to saying 36 and a half if we were estimating. Okay. Now, if I was, say, rounding 36 and 1/5, okay, using this same fifths model, this 1/5 is closer to 0, which means the fraction would be worth 0. So then this would round to 36. Okay, so your fraction is telling you, are you rounding down to the whole number that you started with? Or if I needed to round it up, like in some of the problems where we may round to 1, okay, instead of rounding to 1, the fraction would turn into 1. So for this problem, let's say I had 36 and 4/5. Okay, 4/5 itself rounds to 1, right? So then I would say 36 and 1 more would be 37. I wanted to go over this a little bit because it's something that we are going to need throughout at a point in Module 7. So it was good to kind of throw that in at this point to get you prepared for rounding and estimating and checking reasonableness with mixed numbers as well as just regular fractions. Okay. Hopefully this helps you with our first lesson of Module 7. Best of luck.